Kia ora, Year 10. This is the first video that I'm going to do to help you revise for the end of year assessments. So if you're in my class, you will have been doing lots of work using Dr. Frost for the key skills, and now they're going to be all mixed up in here. So I'm going to start with the unistructural questions. I'd like it if you could have your calculator and your pen and your maths book out as you work through this video. It's going to go for a full 15 minutes and I'll just see how far I get. So these first four questions are ones that we will probably do on the calculator. This one I'm definitely going to do using my calculator. I could work out 1.2 cubed by hand, but we're allowed calculators, so I would use it for that one. This one we can either do on the calculator or just in our heads. This one I would like to do as if we didn't have a calculator, but you can use your calculator to check your answer. And this one here, as it turns out, we can do this one without a calculator. So I know that in the exam, most of you are just going to grab your calculators and do these, and that's fine, but there's some maths skills underlying them. So this first question here is testing whether you understand order of operations. So 3.2 plus 4.7 squared minus 1.2 cubed. Now you can put that into most calculators these days and it will work it out correctly, but we could do it in slower steps. And what we do first in here is we're going to do the exponents in here and the exponents in here. So that gives me 3.2 plus 4.7 squared, using our calculator, is 22.09, and 1.2 cubed is 1.728. Okay, so just looking at that, we end up getting 23.562. Now I'm pretty sure I'm going to make a mistake somewhere in this video, so I'll give a fruit burst to the first person who politely tells me where that mistake is, but I think that one's right. Okay, the next one is looking for the fifth root of 243. So we can do this on our calculator if we know how to use the right buttons. The fifth root means that we need to find the calculator button that's got the little n on it. And the n here is going to be 5, right? So I'm going to show you how to do that in class because I haven't got a calculator emulator set up on my home laptop. The other way to do this, if you're not using your calculator, is to look at it and see if it's a common power, right? And it turns out that it is. So if you think about 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2, and that one works out to be 32. Now we could do the same thing with 3 to the power of 5. And 3 to the power of 5 is 3 times 3 times 3 times 3 times 3. So just looking at this quickly, we've got 9 times 9, which is 81, times 3, which is 243. So quite a few of you will probably just have spotted that the fifth root of 243 will be 3. Or you can get there on your calculator. You don't need to show any working for that one. Okay, you also don't need to show any working for this one, the one where we had 23.562. Now for this next one, we've got some fractions to add up. And this goes back to what we learned in Year 9 or before about adding fractions. 2 of these are written as mixed numbers, and the last one's an improper one. Remember, when I'm adding mixed numbers, I can split off the whole number part and then just worry about the fractions. So, for example, if we just want to do 2.5 plus 1 1/3, we can split that up into 2 plus 1 plus 1/2 plus 1/3. And that works quite well and makes the fraction part easier. So we're going to do that here, but first of all, we've got 15 over 7 as an improper number. So we're going to change it. We're going to have 2.5 plus 1 1/3, and then 15 over 7 is 2 1/7. So to add these up, now we have 2 plus 1 plus 2 plus 1/2 plus 1/3 plus 1/7. And as I've said twice already, if you want to do this on your calculator, it's fine, but being able to add basic fractions is a skill worth having. So I'm going to go through it the long way. So we've got 5, and then we've got to add up all of this. So we need a common denominator. the lowest common multiple of 2 and 3 and 7 will be 42. So let's see what we get here. Well, 1/2 is equal to 21 over 42. Remember that what I do to the denominator, I also do to the numerator. And in this case, I'm timesing both of them by 21. Same thing with the 3. 3 watts are 42. 3 14s are 42. So here we have plus 14 over 42. And lastly, we've got 1/7. 7 times what gives me 42? 7 times 6. So we have 1 6s are 6. All up, that gives me 5 plus 41 over 42, which we can write like this. Now, I suspect that whoever wrote this exam didn't intend you to do all of that work. Well, maybe they did. I would like that answer given as a fraction. So if you do that on your calculator, you might get a decimal answer, and that's not so nice. So I'd like the final answer here to be 5 and 41 over 42. If instead of doing this with mixed numbers, you went to improper fractions, the question would go like this. We've got 2 1/2 plus 1 1/3 plus 2 1/7. So this time we're going to make them all into improper numbers. So that's 5 over 2, right? So 2 2s are 4, plus 1 is 5, plus 4 thirds, plus 15 sevenths. So as before, we're going to get our common factor, which common multiple in the bottom, which will be 42. It's just that these numbers now up the top are going to be a wee bit bigger. So 5 times 21 gives me 105. 4 times 14 is going to give me 56. And 7 6s means that I have to multiply 15 by 6, and I get 90. So if I add all of that up, I get 251 over 42. Splitting out the whole bits gives me 210 plus 41 over 42, which is the same answer as before, 5 and 41 over 42. Right, that was a very long session that I didn't mean really to do on adding fractions. If you're not comfortable with those, go to Dr. Frost and grab the key skills for number, and there's a whole lot of skills on adding fractions in there that are worth doing. Okay, so the next question is another order of operations one, where we've got a fraction. What we want to do with this is to put brackets around what we've got in the top line, because when we've got a fraction sign, we're grouping the stuff in the numerator and we're grouping together the stuff in the denominator. So for this one here, the numerator works out to be 8.8, and then here we've got 2 times this stuff in brackets is 4.8. So that gives me 8.8 over 9.6. Now, yes, you can throw that into your calculator and you'll get an approximate decimal answer. Or you can simplify that fraction nicely. So we can times the top and the bottom by 10, and we get 88 over 96. And now we can divide 8 into both of those, right? So we're looking for the highest common factor in here, and we get 11 over 12. Now, again, if you're not confident with these steps here, then go and find some simple key skills work on simplifying fractions. All right. It actually gets easier from here, guys. So in some ways, those first questions are quite mucky. So on to now page 2. And we've got a bunch of number stuff, some algebra, and then some trig. And I've got about 6 minutes left. So to find a percentage of an amount, I convert the percentage into a decimal. So 13% is 0.13, and it's 0.13 times 3,720. What does that give us? Let's see. I did this before, and I've left my calculator somewhere. So that works out to be this, $483.60. So don't just leave it like that, because when we've got money, we deal with dollars and cents. So make sure that you write 60 cents in there. The next two questions are on standard form. Now, if you're in my class, we did this pretty quickly at the start of the year, and we haven't looked at it much since then. But remember, it's a way of writing really big and really small numbers efficiently so that we can understand them. The first part of standard form is that we want to have one number here and then whatever else we need after that. So we're going to make this 3.87 times 10 to the power of something. Okay, so now we've got to figure out what we're multiplying it by. So let's put our decimal place in here. So we've got 38,700 million. And we've got our decimal point here. So we need to be multiplying by 10 to the power of something. We can figure out how many times we're multiplying by counting back 3, 4, 5, 6, 7, 8, 9, 10. So this number is going to be 3.87 times 10 to the power of 10. Now, to make sure you understand why that works, go back and go over my video on how to convert into standard form. Okay, because it's all to do with decimal place value. The next one is one where we have to go from standard form into normal form or decimal form. And this is going to be a very small number. So 2.17 times 10 to the power of -3. Well, we can think about what this one means. It's 2.17 times 1 over 1,000. That's what the negative power means. So this 2 is in the ones column, and now it's going to be in the thousandths column. So it's going to be 0.00217. So we can check this back to see if we've got it right by putting the 2.17 decimal point in here and just moving it back 3 and having a look and checking that it works. And it does. Okay, I'm just going to do one more of those. If you had 4.56 times 10 to the -2, that would equal 0.00456. No, it wouldn't. That's gone wrong. Too many zeros. We know that this means 100, so it would be 0.0456. Okay, and if we move this over, what we're doing when we say move it over is we're multiplying by 10 each time. Okay, so that's those two done, and I've just got time to do a little bit of the algebra and a ratios question. This next question is using the idea of like terms. So we have to simplify this. We put the p's together and we get 3p minus 4p, so -p. And then we put the q's together and we get plus 9q. So that's one way to write it. Or we could also write it as 9q minus p. For question 5, we have to split the total into the number of parts. So 13 plus 3 is 16. So one part will be 512 divided by 16, which is $32. So 13 times 32 gives us what? How can I not do that? I must be tired, right? 13 times 32 is 416, and 3 times 32 is 48. So this goes to the first person, and this goes to the second person. Just one last question. Increase $248 by 17%. That works out to be, let's see, you know what? I'm going to save that for the next video because we've run out of time. Thanks for watching, and I'll get on to the relational questions and the rest of the unistructural ones tomorrow night.